Class 11th Chemistry, Chapter Unit 1, Some Basic Concepts of Chemistry, Lecture 1. In this first lecture, we shall discuss about some basic concepts. Let us start with the nature of matter. If you see around, you can put the physical entities under four categories. Number one, that you may call matter. Number two, that is energy. Number three, space. And another important entity you can see, that is time. Though there are other entities too. Now let us restrict ourselves only these four quite common physical entities. Chemistry studies about matter, its composition, properties, and energy transfers in chemical processes. Let us first discuss about nature of matter. In previous classes, you have studied that the matter has mass. What does it mean? We attribute this property to the matter. What does it mean? You just have a look at. You focus on this. This is just I apply force on this. What I observe that it resists me when I push it. If I take another entity, or you can say if I double it, then the resistance gets doubled. Means I feel a force back. This property that resists change in state of motion, this property of the matter is because of this. Means it has mass. And this is called this property of mass is called inertia. Means matter resists its state of motion, and to change the state of motion, force is required, and that force and the acceleration produced in the object are related by this equation, that is Newton's equation. If we know the force, we know the acceleration, we can come to know about the mass produced. We can come to know about the mass of the body in which acceleration A is produced. and thus the mass is calculated, that is termed as inertial mass. Another property is that any material object having mass that is surrounded by gravitational field. What does it mean? Means if any other object, see this is one object, this is surrounded by what we say gravitational field. If any other object or material object having mass that is brought in this field, it feels a force of attraction. Means they would try to come closer. This is gravitational attraction or gravitational force of attraction. This is a fundamental force. Therefore, mass has inertia and mass also produces gravitational field. Gravitational field means it exerts gravitational force of attraction on any other object having this property. So many times students they get confused between mass and weight. Here, suppose here is the duster, right? This duster had certain quantity of matter that we call mass. And here at this position, if I leave it, then it falls down. Why it falls down? The reason is it is in the gravitational field of Earth. Just I told you that this is gravitational field of Earth, we can say, and here this is just a force of attraction exists between this and duster. That is why duster moves towards the Earth. Earth also moves towards the duster, but its mass as compared to this is infinitely large. That's why its movement towards the duster is almost zero. Remember that any force acts like a spring. Either it's a compressed spring or stressed spring. If it is a stressed spring, then that's like the force of attraction, and equal force acts on both the objects. Remember that it can never happen that a force acts only on a single object. Every force acts on two objects at the same time in opposite directions with same magnitude or equal magnitude. So what we are talking about? We are talking about that it falls down. When it falls down means this is experiencing a force. The force experienced by this due to the earth or any celestial body or any heavenly body by an object, if that force is experienced, that force is weight. That force is weight of that object. Therefore, if we want to know the force experienced by this duster due to the earth, we must know the mass of this duster, mass of the earth, and distance of separation. Means here Newton's another law, that is law of universal gravitation, that works, this is force of attraction due to gravitation. This is universal constant. Here this m1, capital M, stands for the planet or the earth, and this F is the weight. Means the weight of this depends on the mass of this and also mass of the second object or the celestial body, and also the distance of their separation. While its mass is independent of all these things or all these parameters, it remains same wherever you carry that. I hope it's clear to you the difference between mass and the weight. So we are discussing about nature of matter. We just discussed about one property, that is matter has mass. First we discussed about the nature of matter. Now at number 2 we discuss states of matter. Matter can exist in 3 states generally: solid, liquid, and gas. Possibly you have experience of having a look at all these states. Solid, this is solid, this pen is solid, this duster, this is solid, this board is solid. What are the properties of these? If we have a look at, what do we see? That the volume of this duster, that is a definite volume. It has got a definite shape also, and it has a certain density also. If volume is definite, obviously it would have a definite density at a given temperature. And if we have a look at liquid like water, then what we see, that volume is definite but not the shape. Liquids take the shape in which they are placed. Why that happens and what's the difference at micro level or nano level that they behave differently? Solids, here these are the solid particles, molecules or atoms. In solids, these can simply vibrate about their mean positions. These molecules or the ions or the atoms, they can simply vibrate about their mean positions. Means this 1, 2, 3, 4, 5, 6. One is surrounded by 4, 2 and 5. 2 is surrounded by 1, 5 and 3. And relative position remains the same if it is a true solid. I am not talking about this Here it vibrates, it also vibrates, it also vibrates. These keep on vibrating due to the thermal energy. If the temperature is above 0 Kelvin, and remember that nothing in the universe is at 0 Kelvin, that means what? Every solid object has vibrating molecules or the atoms or the ions, and they keep on vibrating continuously and they keep on emitting thermal radiations and also keep on receiving thermal radiations, and equilibrium is reached when temperature is constant. You must remember it. What happens when some heat energy is supplied to this? Usually this solid turns into liquid state. What happens? This vibrational energy exceeds the force of attraction between one molecule and another, which was not earlier allowing these to go away. If this vibrational energy increases so that it goes away from this force of attraction and they start roaming about throughout in this means it takes the position of 2, 2 comes in position of 1, 3 takes the position of 2, or similarly 6 takes the position of 5, or randomly they keep on roaming about. But still they don't have kinetic energy enough to overcome the force of attraction between them completely. Therefore, they cannot go far away. And if we keep on supplying heat, then what happens? These get so much kinetic energy that they can get rid of the force of attraction, they can overcome the force of attraction, and they start roaming about throughout the space available. And that is gaseous state. I have taken a bottle. You can see here. This is bottle. In this bottle, I have placed these colored beads. These represent the molecules. Here in the solid state, these are simply like this. Means these can simply vibrate. That is the solid state. When it is the liquid state, this is somewhat like liquid state. And what is the gaseous state? I provide more energy. I am blowing this. I am blowing air. Then you can see that how it turns into gaseous state. That was the gaseous state. Now again in the solid state. Right? See again. Is that clear? Through this activity, I tried to explain that what happens when energy is changed or increased or decreased of the molecules. If we decrease the energy of the gaseous molecules, they turn to liquid and then to solid. And if we increase the energy of the molecules, then from solid they turn to liquid and then to gaseous state. Next I discuss about at number 3. Composition of matter. Matter can be pure substances or can be mixtures. Remember that nothing can be 100% pure. Practically, that's not possible. Pure substances can be either elements or can be compounds. And mixtures can be homogeneous. Homo means same, geneous means composition, or can be heterogeneous. Hetero means different, geneous means composition. So pure substances can be elements. Elements are what? Elements are the substances that cannot be further broken into simpler substances through chemical or physical means. Here, chemical or physical means, those are not nuclear processes. Elements like iron or copper or hydrogen or oxygen or carbon and so on. These all are elements. If we take them only one at a time, then that's a pure element. The atoms of these are similar. Similar means they have same number of protons and electrons. Then they belong, all these, if they have same number of protons, then they belong to the same element, and that's a pure substance. And here in the compounds, the molecules of the compounds are made of two or more than two elements chemically combined. For example, water. In water, one is oxygen, this is oxygen atom, this is hydrogen atom, this is hydrogen atom. If we take a sample in which all, this is symbol for oxygen, if we take a compound in which all the molecules are like this, then that is pure water. It means in the compounds all the molecules are alike, but in the molecules all the atoms are not alike, means they don't belong to the same element. They belong to the two or more than two different elements which are chemically combined. Next, here are the mixtures. Mixtures means when we mix two or more than two substances. Those substances can be element-element, element-compound, or compound-compound, or compound-compounds. Then that's a mixture. That mixture can be homogeneous. Homogeneous means the composition is same throughout, and this composition is like this. Here two kinds of molecules. This is one kind of molecule, this is another kind of molecule, and this is another kind of molecule, this is one kind of molecule. All these smaller ones, they belong to the same substance, means maybe compound or element, and the bigger ones belong to the another substance that may be a compound or an element. If they are mixed like this, means distributed evenly throughout, then that is a homogeneous mixture. And if this composition is not like this, instead that is like this, so what do you see here? Here these molecules of one type, and here the second type molecules, those are not evenly distributed. That is why this is heterogeneous mixture. And this particle size may be small or big one. Depending upon the size of this, we further categorize heterogeneous mixtures into colloids or maybe suspensions that we shall study later. Here I show you a few examples. Here is water, and I take salt. This is water. I put salt into it. This is common salt. And on mixing this, after some time, what happens? The salt dissolves in the water and gets distributed evenly throughout. After some time, you can see here that it has dissolved in it and it has distributed itself throughout the water. Therefore, it is homogeneous mixture. Remember that salt gets also ionized in the water. Now, if we keep on adding salt in this, then what happens? Even after quite a long time and keep on shaking, what happens? Some salt that remains here at the bottom, means only a certain amount of solute can be dissolved in certain amount of water. We shall study about that later on. Now at this equilibrium state, what happens? Here the salt particles going from its solid state into the water and the particles coming from water to the solid state. The rate becomes equal and we get a saturated solution. Equilibrium has been attained at this stage. So this is above level, not here at the bottom, this water up. This is homogeneous mixture of salt and water. Here I show you another mixture. Here this is oil. In this oil I put water. You can see here that this is, despite we keep on shaking it, even then what happens? It does not form a homogeneous mixture. Means here at the top it's the oil, more water less. Here water more, oil less. This is not homogeneous mixture, and that's why these don't dissolve altogether. Such is a heterogeneous mixture. Homogeneous mixtures are called solutions. In the end, I tell you that what we learned today, at number one, we learned that what is the nature of matter? Matter has mass. Matter has mass. Number two, we studied that matter exists in three states. Means we studied states of matter. At number three, we studied composition of matter. In nature of matter, we learned that matter has got mass. That mass has inertia and also that causes gravitational force of attraction between the two objects having masses. At number two, we studied about the states of matter. Generally, matter exists in three states: solid, liquid, and gaseous state. Solid state has the lowest kinetic energy in its molecules. When it turns into the liquid state, the kinetic energy, which was just vibrational in the solid state, that turns to the translational and rotational motion. And in the gaseous state, the translational and rotational motion gets enough to get rid of almost all kinds of forces of attraction between the molecules, and the molecules start roaming about throughout the space available. And at number three, we learned about the composition of matter. Matter can be pure or matter can be mixture. In nature, usually we find the matter in the state of mixtures. Pure matter can be either in the form of elements or in the form of compounds. That's it, today's lecture. We shall continue this chapter or unit in lecture number 2. Till then, goodbye.